What is the hardest GCSE maths question? A paper sat by 16-year-olds in the UK. Perhaps it's the long 5 markers at the end of the paper, or a tricky trig question at the start. In practice, it's the 1-mark questions which are found by students to be the hardest. Although worth the least amount of marks, they are amongst the poorest answered questions, and in June of 2018, the GCSE Maths Paper 3, set by the AQA exam board, proved exactly that. Turning to page 9 of the paper, we see a seemingly tame 1-mark question on rhombuses. Tick all of the statements that are true for any rhombus. If you want to have a go, pause the video here and tick which of the boxes you think are correct. We'll continue in 3, 2, 1. That year, little did students know that this mere 1-mark tick the box question would be the toughest on the paper, with, quote from the examiner's report, very few correct answers. Let's take a look. For almost any question involving geometry, drawing a diagram, a large, clear one, is a good place to start. For a rhombus, the classic tilted square shape, all of the 4 sides are congruent, equal in length. Also, the 2 pairs of opposite sides are parallel to each other. To learn more about parallel lines and angles within them, click on the pop-out banner above. Speaking about angles, in a rhombus the opposite angles are equal, like so. Having drawn this diagram labelled with our current knowledge of the shape, all of the options focus on the shape's diagonals. So let's draw them on. Diagonals in a rhombus are lines that connect the opposite vertices together, bisecting the angles from where they're drawn, like so. They intersect each other at a right angle. The first statement states the diagonals are lines of symmetry. We need to check if the diagonals cut the rhombus into exact halves. If we were to fold the shape along the diagonals, both halves should match. Highlighted in pink is 1/2 of the rhombus split by the longer diagonal. Left in white is the other half. These form a pink and a white triangle which are congruent as they both have the same set of side lengths, 2 equal sides of the rhombus and a shared side of the diagonal. So this diagonal is a line of symmetry. Let's check the other diagonal. Again, across this one, both the pink and white triangles share the same set of side lengths. So this diagonal is also a line of symmetry. As both are lines of symmetry, we can tick the first box. The second statement states that the diagonals bisect each other. Bisecting is to divide something into 2 equal parts. In this case, we need to check if the diagonals are split into 2 equal lengths by the other diagonal. As we've drawn onto our diagram, opposite angles in a rhombus are equal, and since the diagonals bisect the angles from which it's drawn, the longer diagonal is split into 2 equal length parts, like so. Again, due to splitting the angles equally on both sides of the diagonal, the shorter diagonal is also split into 2 equal parts. This means our second statement is also true. The diagonals bisect each other. Moving on to the third statement, we need to check if the diagonals are perpendicular. If 2 lines are perpendicular to each other, the angle between them is 90 degrees. Looking at our diagram, we've already drawn a right angle to show the angle between the diagonals. Right angles are simply 90 degrees, so the third statement is also true. A 1-mark hat trick. Finally, the fourth statement. For any rhombus, are the diagonals equal in length? From our diagram, clearly the diagonal from bottom left to the top right is longer than the diagonal from the top left to the bottom right. Why is this the case? It's due to the angles being different. While we know the opposite angles in a rhombus are equal, angles on the same side, like the ones in pink, aren't. If they were, the shape would be a square. Therefore, the diagonal connecting the larger angles is going to be smaller than the diagonal connecting the smaller angles together, as shown in our diagram. So that's the final answer. You must tick all and only those 3 top boxes to get the sneaky 1-mark. How did you do, and what are some of the other seemingly easy but tough maths questions you've come across? Feel free to comment below to share with the community. This question hammers home the practice of drawing a nice, large, clear diagram to note down everything you already know and apply that knowledge to a question. Thanks for watching Beat the Calculator. See you next week.